Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening to everyone who is watching this video right now. We are Group 2 and today we will present our project with the title Implementation of Dynamic Port Forwarding for Secure Data Transmission, which is derived from the topic Security Protocol Analysis, SSH Tunneling versus L2TP VPN. Our group 2, consists of 4 people. The first one, me. My name is Mitchel Mohamad Affandi, and alongside me I have 3 of my colleagues, which are Abraham Benedict, Bagas Maharda Wisesa, and finally Hilmy Baihaqi. In this presentation, we will demonstrate how we secure data transmission using 2 different tunneling architectures. The main reasoning behind this is because we acknowledge the increasing reliance on public networks exposes users to critical data interception risks. As illustrated below, the 2 most prevalent threats are sniffing and man-in-the-middle attacks, which necessitate secure tunneling methods to protect data and bypass restrictions.
So guys, our main objectives for this project are straightforward. First, to establish a secure SSH tunneling environment utilizing dynamic port forwarding. Second one is to validate security effectiveness by comparing plaintext HTTP versus encrypted SSH packets. And the third one, or the finally one, is to evaluate the efficiency differences between SSH and L2TP VPN protocols. So, to explain the first concept, I will invite Mr. Bagas.
Let's start with the SSH tunneling. As illustrated in the diagram, SSH secures transmission by encapsulating user traffic inside a private channel. And then the data travels through the firewall securely, reaches the SSH server, and is decrypted. And finally, forwarded to the application server. This ensures confidentiality even when using public networks.
Moving to the technical implementation, for the environment we use Ubuntu Server 22.04 as the host and Windows as the client. Here I have also provided the list of the Ubuntu terminal commands so that you guys can try this at home and implement the same thing that we've done here. On slide 7, you can see the server configuration. I verify the IP address, which is 192.168.0.250, and ensured the Open SSH service was active on port 22. Then, from the Windows client, I initiated the tunnel using the command ssh-d 8080, which activates dynamic port forwarding.
After the tunnel was active, I configured the client side on Firefox. As seen in this slide, we set the SOCKS host to 127.0.0.1 on port 8080 using SOCKS v5. This configuration forced the browser to send all traffic through Mitchel SSH tunnel instead of the normal internet connection. First, the proof of traffic interception. In the top of image, without tunneling, we can clearly see the HTTP protocol and the source of IP 192.168.18.3 coming directly from the client. However, in the bottom of image, with SSH tunneling, the source of IP changed to the Ubuntu Server's IP, or 192.168.18.76. This proves that the proxy is successfully forwarding our request.
Now here is where things get interesting. So we encountered a technical challenge during packet capturing. As seen in slide 10, Wireshark on Windows failed to capture the local SSH packets due to the loopback optimization on the bridge adapter. To solve this, I perform a server-side capture using tcpdump on the Ubuntu terminal, which is shown on slides 11. The result confirms that the traffic is indeed encrypted, As we can see here, we don't see any HTTP headers, only TCP flags and encrypted payload data flowing through port 22.
Based on that testing, here's the mechanism flow. The request starts from the user laptop, goes into SOCKS proxy, and then gets wrapped in the SSH protocol, travels through the encrypted channel, and finally decrypted by the Ubuntu Server before reaching the target web. In summary, SSH tunneling effectively hides the payload and provides a stable connection for specific applications like web browsing. Now let's move to the second protocol, it's L2TP IPsec VPN. Unlike SSH, this protocol uses double encapsulation, and L2TP builds the tunnel and IPsec encrypts the data. This hides not just the browser traffic, but entire device geolocation and IP address.
For the VPN server, I use a setup script on the Ubuntu VM. As seen in the logs on slide 15, the script updated IP tables and configured the IPsec PS key or pre-shared key. Once the server started, the VPN server was ready to accept connections on the public IP.
On the client side, I add a new VPN connection in Windows setting. We selected L2TP or IPsec with pre-shared key. As you can see, the status is connected and the duration timer confirms a stable activation.
Now this is the critical analysis for VPN. The capture shows the IKE Phase 1 negotiation starting on UDP port 500. However, because the system detected a NAT environment, it automatically switched to UDP port 4500 for NAT transversal. The data payload is fully encapsulated in ESP packets, ensuring complete encryption.
Here's the L2TP mechanism. It affects system-wide traffic. The filter interface adds the L2TP header, then encrypts it with ASP IPsec. It travels via UDP 4500, gets decrypted by the server, and sent into the internet. This validates that L2TP secures the entire operating system connection.
Well, thank you Bagas. Now, let's look at the protocol analysis based on our experiments. Here are the key of the difference. First, regarding the OC layer, SSH works at the application layer, or we can say like layer 7, while L2TP works deeper at the network layer, or we can say like layer 3. Second one is encryption. SSH uses SSH v2, whereas L2TP relies on IPsec or ESP, which is the industry standard for VPNs. And finally, the scope. SSH is great for specific apps like Firefox, but L2TP secures the entire device connection system-wide. Based on that comparison, we arrive at our conclusion. First one is data confidentiality. Both protocols successfully concealed packet content from sniffing. The second one is practicality. SSH is better for quick ad hoc browsing security. The third one is success. We successfully established and validate the environments as per the assignment requirements.
For transparency, we utilize AI tools in this assignment to assist troubleshooting and diagnosis of network errors, verifying our packet capture analysis, and refining our documentation language.
That concludes Group's 2 presentation. We hope this analysis provides a clear insight into SSH and L2TP tunneling. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.